Today we are going to start the 4.4 lesson, solving exponential equations and modeling. So we are going to learn how to solve exponential equations and how to do the modeling using exponential equations. So on the first time, I have a warm up. Complete the table and write an exponential equation that best fits the data below. You can use your calculator. So the formula to find the exponential equation is f of x, which is equal to a b to the power x. So what is a? It is the first term, and the first term here is 10. And what is b? B is the exponential growth. So we will find the exponential growth like this, that between 10 and 15 it's 15 divided by 10, which is equal to 1.5. Between 22.5 and 15 it's 22.5 divided by 15, which is equal to 1.5. So b will be 1.5. So writing this in the form f of x is equal to a, which is 10, b, which is 1.5. Now we need to calculate for x is equal to 3. So we will put 3 over here and we will get our desired answer by using calculator. So it would be 33.75. Similarly, we will do for a b to the power x. A is 10, b is 1.5, and here x is 4. We will get 50.625. So we can write these values in the table: 33.75, 50.625. Okay, solving exponential equations. Use an approximation to solve each of the following equations for x. No calculators. So if 3 to the 1 is 3, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, so 3 to the power x is 11, because 3 to the power 2 is 9 and 3 to the power 3 is 27. So 3 to the power x is 11. So what would be x? It is between 9 and 27. So it's nearest to the 9, so it's 2.2. Can be 2.2. It's an approximation. So similarly, we will do for 2 to the power x is 15. So let's start with 2 to the power 3 is 8. 2 to the power 4 is 16. So 15 is between 8 and 16, but it is nearest to the 16, so it's nearest to the 4. So x would be 3.9. So with the help of this approximation, we're going to solve this. Okay. Algebraically solve each equation for x. So for solving algebraically, this is called the base and this is called the exponent. So where bases are equal, we will make exponents equal. So x minus 1 is equal to 5, x is equal to 5 plus 1, x is equal to 6. Okay, here bases are not same, so we will make the bases same. We can write 49 as 7 square. So now bases are same, we can make exponents same. 2x minus 3, which is equal to 2. 2x is equal to 2 plus 3. 2x is equal to 5. X is equal to 5 by 2. Okay. Algebraically solve the following. Okay, now the rule is we need to make the bases same. So it's 4 and it's 8. Bases are not same. तो जब बेसिस सेम नहीं होंगी तो हम क्या करेंगे कि बेसिस को सेम करेंगे. तो 8 को 4 बनाने के लिए व्हाट वी आर गोइंग टू डू इज़ 4 टू द पावर 2 इज़ 8. और ये जो x प्लस 1 है ये क्योंकि ऑलरेडी एक्सपोनेंट में है तो ये 7 आ जाएगा. नाउ क्योंकि बेस सेम है तो एक्सपोनेंट सेम हो जाएगा. ओके अब यहाँ पे भी हमारे पास बेस सेम नहीं है. So if the base is not same, we're first going to make base same and then we will make the exponent same. So it's 3. 3 can go over here on this side and divide by 48. So it can be written as 2x is equal to 48 divided by 3. can be written as 2x is equal to 16. So 2x is equal to 2 to the power 4. 2 to the power 4 is 16. So bases are same. We can make exponent same. X is equal to 4. Okay. Now this. Again, it's 1 over 125. So can we write it 5 to the power minus 3? Because 1 over 125 is 5 to the power 3. And when 5 to the power 3 is coming in, will come in the numerator, it will get the negative sign. So bases are same, we can make the exponent same. Okay, now here again bases are not same, so let's first make the bases same and then we're going to solve this out. 27 can be written as it's the power of 3 to the power 3, 3x plus 1. 1 over 3 can be written as 3 to the power inverse, x plus 2. So we can write it like this: 3 to the power 3, 3x plus 1, which is equal to 3 minus x plus 2. So now bases are same. Here it is 3, here it is 3. When bases are same, we can make exponent same: 3, 3x plus 1, which is equal to minus x plus 2. So 9x plus 3 is equal to minus x plus 2. 9x plus x, which is equal to 2 minus 3. 10x is equal to minus 1 and x would be equal to minus 1 by 10. Okay, modeling with exponential functions. If a quantity grows or decays by a fixed percent or regular intervals, the pattern can be modeled using these exponential functions. So exponential growth can be written as a of t is equal to p 1 plus r to the power t. What is p? P is the initial growth, r is the growth rate or growth decay, t is the number of times intervals that have the past, a is the final amount. So if it is growth, we will use plus sign over here. If it is decay, we will use negative sign over here. So let's solve some questions using exponential growth and decay so that we could know that what is the practical applications of these. Okay, so the first question is, you purchase an antique state for $450. The value of the state increases 5.5% per year. So 5.5%, how much is it worth after 20 years? So it was 5.5%, which can be written as 5.5 by 100, which can be written as 0.055. Now it's asking after 20 years how much was increased. So formula is a of t is equal to p 1 plus r t. This is the formula. Okay, so now solving it. What is a of t? We need to after 20 years. So what it was, a principal amount was 450. 1 plus r is 0.055 and we need to find t is 20. So we need to find a of 20. Okay, let's solve it. So very simple, use your calculator. Do 1 plus 0.055 to the power 20. You will get 2.91775 something. Multiply it with 450 and you will get 1312.990871. Okay. When will the state be worth $2000? Okay, now the worth of the state can be $2000. So when it can happen? So when means time. So a of t is equal to p 1 plus r to the power t. So it's 1 2 3 given. Principal amount is 450. 1 plus 0.055, and we need to find out t because it's when. So 450 will be divided over here. It's 2000 divided by 450. Okay, so let's divide 2000 divided by 450. You will get 4.44. Taking log on both sides, we will get log 4.44. It would be 0.647, which is equal to t. This t is going to come in the start. Log 1 plus 0.055, which is equal to 1.055. So 0.647 is equal to t log 1.055, which is equal to 0.02325. Now it will be divided over here. 0.647 divided by 0.02325, so it would be 27.860 years. Okay, a jet ski initially cost $4,200, but it depreciates at 9.4% per year. When will this jet ski be worth 2,500? So again, it's asking when. So whenever it's going to ask when, it means time. So a of t, a jet ski cost 4,200, which is equal to p was, sorry, p is 4,200, which is the initial amount. Cost 4,200, so cost is the initial amount. Nine point four divided by 100, which is equal to 0.094 to the power t, and it will be worth 2,500. So it's the, so again 2,500 divided by 4,200, 1 plus 0.094 to the power t. So 2,500 divided by 4,200, which is 0.595. 1 plus 0.094 is equal to 1.094. Okay, so log 0.595 is equal to minus 0.225. So it would be 5.7 years. Okay. You have inherited a diamond ring that had an appraised value of 2,500 in 1980. The appraised value has increased by approximately 6% per year. In what year will the ring be worth 35,000? So again the same thing is happening. We will put the formula. A of t is equal to p 1 plus r to the power t. So very easy. What was the actual worth of the ring? You have inherited a diamond ring that had an appraised value, means the appraised value is 2,500. So in what year the ring will be worth 35,000? So actual value of the ring would is 35,000, and the principal value or the initial value is 2,500. 1 plus 6% is 0.06, and t is something that we're going to find out. So 35,000 divided by 2,500, it is 14. 1 plus 0.06 is 1.06 to the power t. So we are going to take log on both sides. So it's log 14, 1.14. 45.2859. Okay, so they were saying that you have inherited a diamond ring that had appraised value of 2,500 in 1980. So the appraised value has increased by approximately 6% per year. In what year the ring will be worth 35,000? So worth of 35,000 we need to check. So it's in 1980 it was 2,500. So after 45 years, so 1980 plus 45 years, which will be equal to 2025. So in what year the ring will be worth 35,000? In 2025 ring will worth $35,000. The value of a new 4500 sailboat decreases 10% per year. So here it is the case where it's decreasing. What will be the sailboat rewards? So it's A of t is equal to p 1 minus r t. The value of the new 4500 sailboat, so it's going to be 4500 1 minus 0.1. The value of a new 4500 sailboat decreases 10% per year. Because it's going to be in 1 year. Okay, so $2,500, when will be the sailboat of the word 2500? So for 2500 it's going to equal to 4500 0.9 to the power t, because it's when, so we're going to find t. So 2500 divided by 4500, which is equal to 0.55, which is equal to 0.9 to the power t log. So t will be equal to 5.579 years. Okay. The population of Utopia currently has 40,000 people and is growing at the rate of 3.5% per year. The population of Metropolis currently has 25,000 people, but it is decreasing at the rate of 1.6% per year. When will the two cities have the same population? So first of all, we will go for Utopia. Utopia has 40,000 population, which is 1 plus 0.035 to the power t. So we are going to solve this out, which is equal to 4123 1.035 to the power t. Metropolis, okay, it has 250,123 population, which is depreciates 1 minus 0.016 to the power t, which is 25,0123 0.984. Okay, so now we need to find t. When will the two cities will have the same population? So if you're going to find t, we will equate the two equations. Okay, so now 40,000 divided 250,000 divided by 40,000, 253 divided by 41 to 2, 6.25. Okay, so by solving this, we will get t is equal to 36.267 years. Okay, solve the following exponential equations, approximate where necessary. 2 to the power 3x is equal to 264. So we're going to write make the bases same. 3x is equal to 6, x is equal to 2. 2 to the power 3x is equal to, or we can write, oh, we need to approximate. If we need to approximate, 8 to the power 1 is 8, 8 to the power 2 is 16, 8 to the power 3 is 24, 8 to the power 2 is 64. What is happening here? But we need 20, so it's near a 1, so it's going to be 1.4, not equal to, approximately equal to. Okay, so here is 8x minus 3. We cannot write 32 in terms of 8, but we can write both of them in terms of 2. Okay, so it's going to be 5x minus 4 with 5 square x minus 6. So bases are same, we can make exponent same. It's going to be 6 inverse 11 minus x. Bases are same, so exponents are also going to be same. So is there any power of 8 which can give us 32? Because here it is 32, so there is no power of 8 giving us 32, so we will go and make both of the bases to the 2 to the power 3 x minus 1, 2 to the power 5, 3x minus 2. It seems to be a repeated question. Okay, so 1 over 16 can be written as 1 over 4 square, 4 to the power minus 2. Sorry, it's going to be minus 2 minus 2. And 16 and 64, it can be written in the power of 4. So we are done with it. Okay, so the next we have is Jill is studying a strange bacterium. When she first looks at the bacteria, there are 1,000 cells in her sample. The next day, there are 2,000 cells interviewed. She comes back the next day to find that there are 4,000 cells. Create a table and the rule of the function. The inputs and the decays have passed it after she began to study the sample. And the outputs are the numbers of the cells of the bacteria. So we are going to make a table. T is 0. So the cells were 1,000. When it was T was 1, the cells were 2,000. And when it was 2, the cells were 4,000. Okay, so it's a multiple of 2, multiple of 2. So now what we're going to find is what is base. Base is 2 and A is A of T, which is equal to 1,000 A B to the power T. Your collection of baseball cards goes to 150 in 1988. In 1994, the value of the collection had increased by approximately 7.5% each year. So how many years from 1988 to 1994? Time is 1994 minus 1988, which is equal to 6. So A of T, which is equal to 150, 1 plus 0.075 to the power 6, which can be equal to, after solving them all, it is equal to $231.50. Assume that a DVD loses 60% of its value every year in a video store. Suppose the initial value of the DVD was $80. What is the value of the DVD after 4 years? So A of T is going to be 81 minus 0.6 to the power T. So we need to find A of 4, which is equal to 80, 0.4 to the power 4, which is equal to $2.05. So we have completed this lesson and we have learned how exponential decays and growth occurs in the practical values. Thank you.